Welcome to 26th lecture on numerical analysis. In this lecture we will be studying numerical integration, but in previous lectures we have been studying about numerical differentiation techniques. Right, in this lecture we will study the famous trapezoidal rule to find out integral, the definite integral. The definite integral is the one for which we are given the limits a and b. We have to integrate f of x with some given limits a and b, and using this trapezoidal approximation it comes out to be this b minus a, where a and b are the limits on x-axis, and f of a is the value of the function f of x at a, f of b is the value of this function f of x at point b. Right. So, how do we reach to this answer? On the right hand side, this is the point we reach to by this approximation, that we assume this to be linear in this region from a to b. We assume it to be linear in this region, the straight line in this region. Right, and then we apply the formula that we know to find out the area of a trapezoid. A trapezoid is a geometric shape for which we have two parallel lines. In this case, we have this and this, these two parallel lines, whereas this and these two are not parallel. So these two parallel lines, the height of this left vertical line is f of a, because its value is f of a. So the height of this line is f of a, and the height of this line on the right is f of b, because the axis of the y on the y-axis is f of b. So the height of this line is f of a, the height of this line is f of b. Whereas what is the width of this line? This is, of course, the initial point is a, the final point is b, so the difference is b minus a. So the length of this line, this horizontal line, is b minus a, where the line of this horizontal line is not known, and actually we don't know this, we don't need this, and this line, the width is the same, b minus a. Right. So let's assume a rectangle inside this trapezoid, a rectangle of this pink dotted line. Right, the triangle made by this dotted line, this dotted pink line. So the area of trapezoid can be thought of as the sum of this area and this area. The sum of this area is the area of rectangle, and the sum of and this area is the area of triangle. So the area of trapezoid can be thought of as the sum of the rectangle and the sum of the triangle, this two. Right. So the area of rectangle is simple to calculate. One side is f of a, the other side is b minus a. So we multiply f of a with b minus a, and we find the area of this rectangle. Right, but the total area is the area of this rectangle plus the area of this triangle. The area of triangle is, we know, 1/2 times base times height. So height is the same, b minus a, so 1/2 times b minus a. But what's about this width? This, of course, is f of a, the difference between f of b and f of a. So this small segment is actually f of b minus this f of a. So f of b minus f of a is the difference between these two, and it's actually the width. This width is f of b minus f of a. So we keep on going. We multiply f of a with b, we multiply f of a with a, it becomes b times f of a minus a times f of a, and we keep on solving 1/2 f of b times b minus a times f of b minus b times f of a and plus a times f of a. All of them are multiplied with 1/2, and we keep on going. This b times f of a. We have one other b times f of a, this one. So this is b times f of a minus 1 by 2 times b times f of a. This is 1 b f of a minus half b f of a. So this is half b f of a. Similarly, we have this minus a f of a plus half f of a. So this is minus half a f of a. Plus we have this written as such, this written as such. Once we have done that, we can take f of a common. We can take f of a common from these two terms. So we are left with 1 by 2b minus 1 by 2a. So we can also take 1 by 2 f of a common. In that case, we are left with b minus a. And here we can have 1 by 2 f of b common, and we are left with b minus a. 1 by 2 f of b, and we are left with b minus a. And then we can take 1 by 2 b minus a common, and then we are left with f of a plus f of b. So this is the same answer as this, b minus a by 2 times f of a plus f of b. So this is the approximate area under this curve, assuming that the line that joins f of a and f of b is a straight line. It's actually a very straight line. It's not drawn very straight, but it is actually a straight line. From f of a to f of b, it's a straight line. Right. So the method is that given f of x, we need to compute this integral of f of x from limits a to b, the definite integral, and we divide this integral. In step number 1, we divide this interval in n subintervals. So we have this x, this is f of x, and we divide it into n subintervals. This a is replaced with x0, and then x1, then x2, xn, and then bxn. To keep things simple, we assume that the difference between the intervals is the same. x1 minus x0 is the same as x2 minus x1 is the same as xn minus 1. Right. So we can divide this integral as this integral in this region, plus integral in this region, plus integral in this region, plus this final integral. So this whole integral from a to b, which can also be written as from x1 naught to xn, because we have replaced a with x naught and b with xn, we can divide them into certain parts and parts. So we can have this integral, the first one with limits x0 to x1, the second with limits from x1 to x2, and the final with limits xn minus 1 to xn. And then we know that, and we'll assume the function to be linear in every region. So if we assume it to be linear, in this region, this means that we'll apply the same trapezoidal rule. So if we assume it to be linear in this region, we'll apply the trapezoidal rule, that is b minus a, where we have x1 as b, x0 as a, b minus a divided by 2, the value of the function at the lower limit plus the value of the function at the upper limit. And we'll keep on doing for all these intervals, for all these integrals, and finally we reach here. And since we have assumed the intervals to be of the same width for all i's, xi plus 1 minus xi is the same as xi minus 1 for all i's. So interval widths are the same. This is all interval widths are the same. So in step number 2, we'll call this as h, xi plus 1 minus xi, and then we will assume it to be x1 minus xi will be replaced with x1 minus x0 will be replaced with h. This will also be replaced with h. So this difference in all cases will be replaced with h. So that would be h by 2. So h by 2 f of x naught plus h by 2 f of x1, h by 2 f of x naught plus h by 2 f of x1, h by 2 f of x1 plus h by 2 f of x2. This is 2. Plus h by 2 f of xn plus h by 2 f of xn minus 1. But you see, we have x1 term x1 here, and an x1 term here. Why? Because we have x1 here as well as we have x1 here. So we have two terms of x1. Similarly, we have an x2 term here, and we will have an x2 term here. We have an xn minus 1 term here, and we will have an xn minus 1 term just before this term. But we will have only one term of x naught and only one term of xn. So all terms between x naught and xn will be doubled. So if we have x2 plus we have another f of x2, we have f xn1 here and we'll have another f of xn minus 1 here. So finally we take h by 2 common from all these terms, and we have f of x naught plus 2 times f of x1, 2 times f of x2, 2 times f of x3, 2 times f of x minus 1, but here we'll have only one term of xn and only one term for x naught. This is very important to note. For the first and the last terms will have only one, but all other terms will be doubled because they will be appearing in the preceding term and in the next term. Right, so we have all two, but the first and the last are single. The first and the last are singles, all others are double. Right, so this is the formula we have reached to, and it's a very simple formula. Now we are ready to solve an example. So what we are going to do is we'll put this formula straight away. Right, let's zoom it out a bit so that this formula and the example, they both are clear. They both are visible. Right, so x squared dx, we need to integrate it, this definite integral, from 0 to 1. So we divided it into n sub intervals, 0.25, 0.5, 0.75. You can divide it in 8 sub intervals, but that will of course increase the volume of work, but your answer of course would be closer to the desired answer. Right, so h would be 0.25 because the width of all intervals is 0.25. So you can divide into 2 intervals, you can divide into 4 intervals, you can divide even in 8 intervals. Right, so f of x of course is x squared. This is f of x. This is f of x, x squared. So x squared dx, f of x dx integrated between 0 and 1 is h by 2. So this is the formula, h by 2. F of x naught, the value of f at the first limit x naught is 0, plus 2 times f of x1 is 0.25, plus 2 times f of x2 is 0.5, plus 2 times f of x3 is 0.75, plus not 2, it's 1, f of x, so f of x4, the last one, f of xn, f of 1. So you know this isn't 2, the first term isn't multiplied with 2, the last term is also not multiplied by 2, but all other intermediate terms, the middle terms, are multiplied by 2. So this is very important. You must remember this one, but the first and the last term are multiplied by 1, not by 2. Right, so f of 0 is, we put 0 here, 0 squared is 0, plus 2 times f of x evaluated at 0.25. So f of x is x squared, so 0.25 squared, plus 2 times 0.5 squared, plus 2 times 0.75 squared, plus 1 squared. So it comes out to be 0.343. Right, and so using this trapezoidal method, we have this. You have evaluated it to be equal to 0.343. But now let's find the exact solution. Of course, we know from the college that x squared integrated between 0 and 1 would give us x cubed by 3, and once you put these limits, it comes out to be 1 by 3, which is 0.333. So the approximate answer, the numerical solution has, the numerical technique has given us a solution equal to 0.343, but it's actually 0.333. So of course they're very close. Let's find the percentage error. Actual minus approximate divided by actual times 100. Actual is 0.33, approximated using trapezoidal technique, the answer is 0.343. So the difference, the absolute value of the difference, if it is negative, it becomes positive, divided by 0.333 times 100. So the error is 3%. Now you have a homework, and what is homework? The homework is to solve the same problem using using n is equal to 2 and n is equal to 8. If you use n is equal to 2, what would be your h? H would be 0.5, and if you use n is equal to 8, the interval width would be 0.125. So let's see what your answer. In this case, when n is equal to 2, your percentage error would be large because the difference between your actual answer and the approximate answer would be large. But if you use n is equal to 8, this percentage error would be small. That would be an interesting exercise as a homework. Right, that's all for this lecture. Thank you.